Hey everyone, you ever drive past a huge industrial plant and just wonder, how in the world do they keep that place clean? Well, today, we are diving deep into one of the biggest, toughest jobs on the planet, the industrial deep clean, for the absolute giants of the energy sector. I mean, really think about that for a second. You're standing in front of a storage tank that's literally the size of a building, and it's caked inside with years of thick, nasty, and often hazardous gunk. You can't just, grab a hose and a brush. So, what do you do? To even begin to answer that, first, you got to understand the sheer scale of what we're calling the industrial gunk problem. So, let's break it down. Okay, so these massive tanks and vessels, they are the absolute workhorses of the energy industry. I mean, they do everything from storing crude oil right out of the ground to handling really complex chemical processing. And all that hard work leaves something behind. A buildup of residue that is tough, sometimes toxic, and just unbelievably difficult to get rid of. And it's not like every tank is the same. Oh, no. We're talking about a whole world of different vessels. You've got your colossal storage tanks for crude oil, then you have these intricate process vessels, things like separators and reactors, and even specialized containers for chemical additives or waste. Each one is different, and each one holds its own unique, stubborn kind of grime. So, when you have a problem this big and this varied, you need a seriously specialized solution. And that brings us to what I like to call the chemical cleaning mission. Look, there are times when sending a crew of people inside to scrub the walls is either flat out impossible or just way too dangerous. And that's when the real experts get the call. This is a super high-stakes field, a mix of advanced chemistry and precision engineering. And it's all designed to keep our energy sector running safe and sound. And this is not just for looks. This isn't about making the inside of a tank look pretty. It's absolutely critical for maintaining what the industry calls operational integrity. Without it, equipment could fail, efficiency would just plummet, and safety gets seriously compromised. It's a non-negotiable part of the business. All right, so how do they actually pull this mission off? Let's walk through the whole thing, step by step. You have to imagine this like a carefully choreographed dance. First up, you have to drain everything out and then degas the vessel to get rid of any flammable or toxic fumes. Safety first, always. Then, if it's safe to do so, crews might go in and manually remove the heaviest layers of sludge. Next, the main event, the chemical application, which often involves these high-tech spray nozzles. After that, you let it sit for a while, the soaking period, to let the chemicals work their magic. Then comes a super thorough rinsing. And finally, a meticulous top-to-bottom inspection to make sure the job is 100% done. But, as you can probably guess, this whole process is loaded with challenges. There are some serious dangers involved, which is why a huge part of the mission is about managing risk and, this is key, choosing the exact right chemicals for the job. And one of the biggest dangers revolves around this term right here, a confined space. Basically, it's any area that's tough to get in and out of and isn't meant for people to hang out in. Think about the inside of a giant tank. The risks in there are huge. Everything from toxic fumes to just not having enough oxygen to breathe. So, to deal with that danger, the safety protocols are, as you'd expect, incredibly intense. We're talking continuous air monitoring, powerful ventilation systems pumping in fresh air, but it gets even more serious. There are fully equipped standby rescue teams, right there, ready to go in at a moment's notice. The fact that they're needed at all tells you just how serious the risks really are. But here's where the science becomes an absolute lifesaver, literally. When you have a really well-designed chemical cleaning plan, it can work so well that it drastically reduces, or sometimes completely eliminates, the need for a single person to set foot inside that dangerous space. That's not just an improvement, it's a total game changer for safety. And the chemistry itself has to be incredibly precise. It's all about matching the chemical to the grime. So if you're dealing with that thick, oily hydrocarbon sludge, you need a powerful solvent-based cleaner that can basically dissolve it. But if you're up against hard, crusty mineral scale, that same solvent is going to be useless. For that, you need a specific acid solution that can chemically react with the scale and just break it apart. Choosing the right one is everything. Okay. So the vessel is clean, the mission was safe, job's done, right? Well, not quite. There's one final crucial piece to this puzzle: cleaning for compliance. Because in today's world, a job like this comes with a massive amount of responsibility. It is not enough to just get the tank clean so it's ready for the next batch of whatever. The entire operation, from start to finish, has to meet a whole maze of strict environmental and safety regulations. And these rules cover the whole project. We're talking about the safe disposal of all that hazardous gunk they removed, strict controls on any fumes or emissions released during the cleaning, and making absolutely sure that all the wastewater from the rinsing is treated properly before it goes anywhere. It's a precision operation right up to the very end. So, when you put it all together, the goal becomes really clear. It's about getting maximum cleaning with minimal downtime. Because every day a tank is out of service can cost a company a fortune. But it's about more than just a clean tank. It's about making sure the massive energy infrastructure that we all rely on every single day keeps running smoothly, safely, and responsibly. It's just a really fascinating peek into a hidden world, right? And it kind of makes you think, what other totally invisible but completely essential processes are out there, quietly humming along, powering our daily lives?